chemistry is about reactions, the interactions of molecules to make new molecules. And the recipe for those sorts of chemical reactions is what we call a balanced chemical reaction. So let's explore what a balanced chemical reaction is. Again, it's a recipe on the atomic level which says we take some molecules, in this case we have hydrogen molecules, H2, represented by red balls for the hydrogen atoms and then this line connecting them together to indicate that there's a chemical bond there. And when these hydrogen molecules react with an oxygen molecule, it turns out that you can make water. And this is a representation for water. Now at this point, don't worry about the representation so much. You don't have to understand how to predict what would happen. All we're really concerned about right now is the fact that there are 4 red balls on this side of the arrow, and 4 red balls on this side of the arrow, 2 green balls on this side of the arrow, and 2 green balls on this side of the arrow. Again, red represents hydrogen and green represent oxygen. So what is a balanced chemical reaction? It's an expression of the law of conservation of mass, which says that atoms are neither created nor destroyed, and consequently mass is neither created nor destroyed in the course of a chemical reaction. That's what you can see in this picture right here. Now we represent what's going on the atomic level with a symbolic equation, which is what we call the balanced chemical reaction. So let me run you through this. First of all, we have a 2 hydrogen molecules, so a 2 in front of the number of hydrogen molecules, plus oxygen molecule going to 2 times water. And these are on the molecular level, so 2 hydrogen molecules, an oxygen molecule, and 2 water molecules, just like we saw in the previous slide. These numbers here are called stoichiometric coefficients. They tell you how many of each type of molecule you need in order to make the reaction work. What is that? That's like a recipe. Certain number of cups of flour, certain number of tablespoons of bacon fat, whatever. And furthermore, it tells you what you should get out. If you're trying to make pancakes or something like that, you know how many cups of flour, how many eggs, how many milk, how many cups of milk, and you know how many pancakes you should get out. That's what this is. It's a recipe, but not recipe in cups or tablespoons, recipe in atoms and molecules. We call the components on the left-hand side the reactants, and we call the components, of which there happens to be only one in this particular reaction, the products. And furthermore, we typically have in parentheses next to the various reactants and products the phase, meaning that is this a gas or a solid or a liquid? In this case, G stands for gas, L stands for liquid. 2 other phases that you're going to see later on are S for solid and AQ for aqueous solution. Now, how do we know that this is balanced? The way we know is that you multiply the coefficient, the stoichiometric coefficient, by the subscript. Remember, the subscript tells you what the molecule looks like. So in other words, this number times this number tells you how many atoms of hydrogen there are on the left side of this reaction. 2 times 2 is 4. And similarly, we come to the product side, and we multiply the coefficient by the number of atoms in the molecular formula, and that gives you the number of hydrogen atoms on the right-hand side. Again, 4. Now, for oxygen, if you don't see a number in front of the reactant, it's implied that it's a 1 there. So 1 times 2 is 2, and then on this side, 2 times 1. So similarly, if you don't see a subscript here, the implication is that it's a 1. So 2 times 1 is 2. So in other words, this represents a balanced reaction on the atomic level. So let's now look at a series of reactions that may or may not be balanced and double check and see if we can make sure that they are balanced or not balanced. The first reaction here is the reaction of iron plus oxygen to form ferric oxide, or iron 3 oxide. This is rust. We have 4 atoms of iron on the left-hand side and 4 atoms of iron on the right-hand side. Remember, multiply the coefficient by the subscript. We have 6 atoms of oxygen on the left-hand side and 6 atoms of oxygen on the right-hand side. So this represents a balanced chemical reaction. Here is the reaction of butane and oxygen to form carbon dioxide and water. If you've ever lit a pocket lighter, that's a butane lighter. Let's balance first for carbon. 2 times 4 is 8. And then on this side, 8 times 1 is 8. So they're the right number of carbons. For hydrogen, 2 times 10 is 20. And 10 times 2 is 20, so it's balanced for hydrogen. And for oxygen, 13 times 2 is 26. 8 times 2 is 16, plus 10 more, that's 26. So this also represents a balanced chemical reaction. This is mercuric oxide. We have one mercury, Hg, on the left-hand side and one mercury on the right-hand side. We have one oxygen on the left-hand side and two oxygens on the right-hand side. So this does not represent a balanced reaction. This equation is not balanced. Okay? And let's put a little check mark to remind us that that was not a balanced reaction. And finally, let's look at this really complicated reaction, which looks like it's titanium dioxide and bromine trifluoride reacting to form titanium tetrafluoride plus bromine, elemental bromine plus elemental oxygen. Titanium, we have 3 titaniums on the left-hand side and 3 on the right-hand side. Let's look at oxygen. 3 times 2 is 6. And 3 times 2 is 6, so it's balanced for oxygen. For bromine, we have 4 bromines, and 2 times 2 is 4, so we have 4 bromines on either side. And finally, 4 times 3 is 12, 12 atoms of fluorine on the left-hand side. 3 times 4 is 12, 12 atoms of 12 atoms of fluorine on the right-hand side. So what have we learned? We've learned that in order for a chemical reaction to be a valid recipe, we need to have it balanced. That means there has to be the same number of atoms on either side of the arrow. What we're going to see in the next tutorial is how you do that starting from a reaction that isn't balanced.